Hey guys, today is Thursday, April 2nd, and this is our nuclear decay and half-life notes. All right, so you know from the previous notes we took that things that are radioactive and nuclear spit off little particles, and therefore over time they get smaller and smaller and smaller. And we can look at the rate at which they get smaller and kind of figure out how old a sample is by determining how much of the original element we have and then how much of it has decayed away. So let's look at the term half-life. That is a measurement of time. So if we had 30 grams of a sample and then over time it went down to 15, that's half, we'd look about how much time that took. Let's say it took 10 days, the half-life would be 10 days. A lot of the samples we're going to look at, though, have a relatively long half-life, like 5,000 years or even a million years to decay. And then there are some samples that decay rather rapidly, so it's hard to keep those because of how fast they are decaying. We're going to look at, first I want to show you some graphs. So go over here. A common way to figure out how old something is, like a fossil or a rock, is through carbon dating. And it's because we've studied carbon so much, there's an isotope of carbon called C14. So if you had 100% of carbon, half of 100 is 50. How much time did it take to get to 50? Well, it's right here, it's not on a line. You'd follow it down and you'd make an estimate in years, so 5,000 some years. And we actually know that number because it's been studied so much. It is 5,730 years for half of it to decay. Well, let's say we have 50 and another half-life goes by. Half of 50 is 25. So 25 is right here. We knew the half-life was 5,700. So if two half-lives go by, we're going to be here. 5,700 times 2 is about 11,014, and that's about where we end up right there on the graph. If another half-life goes by, so we're at 25%, half of 25 is 12.5, we're all the way over here. So you'd add another 5,700 years on and so forth for every half-life that goes by. Now let's look at another half-life. Now this is strontium 90, isotope 90, and we're saying we have 100 grams of it. So we have to figure out what's the half-life of strontium 90. I'm going to give you a few seconds to get an answer in your head. All right, so you have 100. Half of 100 is 50. How long did it take to go down to 50? It took 25 years. The half-life of strontium 90 is 25 years. So we're looking at how much you start with, what is half of that? It's not always going to be 100 that you start with. And then the unit here. This could be seconds. And the past two that we did, they were years. Let's look at how we solve some of these problems. All right, cesium has a half-life of 21 years. You have a 90-gram sample. 84 years have gone by. How much would remain? So I guess this should say you had a 90-gram sample because you wouldn't have that anymore. So I like to make a little tea table of the time and the amount that we have. Okay, so at the start of this, we'll say 0 years have gone by and you have 90 grams. It says the half-life, though, is 21 years. So every 21 years, half of this is going to disappear. So if 21 years go by, half of 90 is 45. And then if another 21 years goes by, which would bring us to year 42, half of 45 is 22.5. But we've got to work our way all the way to 84. So I'm going to add another 21 years because that's the length of our half-life, which is 63. Half of 22.5 is 11.25. I'm still not up to 84, which is where I'm trying to get. So another 21 years brings us to 84, and that's our goal. Half of 11.25 is 5.625. So how much would remain after 84 years? 5.625 grams cesium would remain. Example 2. There are 2 grams of francium left. You started with 16 grams. How much time has gone by? The half-life of francium is 34 years. All right, so they want to know how much time went by. So I'm going to make my chart again, time and amount. And it says I started with 16. And the start is always going to be times 0. Okay. If you have 2 grams of francium left, what I'm going to do is work this through until I get to 2. Because I know every half-life that goes by, half of it goes away. Half of 16 is 8. Half of 8 is 4. Half of 4 is 2. And I'm going to stop there because there's 2 left. The half-life is 34 years. So if one half-life went by, that was 34 years. If another half-life goes by, 34 plus 34 is 68. Another half-life went by to get to 2, plus 34. It's 102 years. They wanted to know how many years it took. 102 years. have gone by. Example 3. What percent of a sample remains after 7 half-lives have gone by? Well, this one's kind of different. We don't know what sample we're talking about, and we don't know how much time, so my table's going to look different. This will be number of half-lives, and this will be percent of sample. Always start at time 0. 0 half-lives have go by, therefore you would have 100% of your sample. If 1 half-life goes by, you're down to 50. If 2 half-lives go by, 25. And remember, we've got to go all the way to 7. 3 half-lives go by, half of 25 is 12.5. 4 half-lives go by, half of that, 6.25. 5 half-lives go by, half of that, 3.125. 6 half-lives go by, half of that, 1.5625. And 7 half-lives go by, half of this one, 0.78125. I'm going to go ahead and round it and say how much is after 7 half-lives? 0.78%. All right, I have 2 practice problems for you. Start with 5.0 grams of sodium 25. That's an isotope. Its half-life is 60 seconds. How much remains after 3 minutes? All right, I'd like you to pause the video and work this problem out. All right, let's see if you got it right. We need our time and our amount. Time starts at 0, and this was in minutes, not years. And it said you start with 5.0 grams. It says the half-life is 60 seconds. So if 1 half-life goes by, you're at 60 seconds, which is 1 minute if we're talking in minutes. So that's kind of an easy thing. And you've got to work your way up to 3 minutes. If another half-life goes by, you're at 2 minutes. And another one goes by, you're at 3 minutes. So now, if 1 half-life went by, half of this is 2.5. Half of this is 1.25. And half of that is 0.625. So how much remains after 3 minutes? 0.625 grams. Sodium 25 remains. All right, we've got one more practice problem. Practice number 2. Arsenic 81 has a half-life of 33 seconds. if 12.5 grams arsenic 81 remain after 132 seconds, how much was there to start? All right, go ahead and pause the video and try this problem. All right, so we have our time, which is in seconds, and our amount. It says it has a half-life of 33 seconds, and we're going to work our way to 132. I'm going to do that first. So 33 seconds is one half-life, plus 33 is 66, plus 33 is 99, plus 33 is 132. Once I hit that number, I know I can stop. We're going to work our way backwards because it says at the end of this, there was 12.5 grams. And your goal is to figure out how much you started with. So if when we worked our way down, we divided it in half, divided by 2, we're going to double it on the way up. So if we work backwards, double 12.5 is 25, double 25 is 50, double 50 is 100, double 100 is 200. So our answer is 200 grams of arsenic 81 were present to start. Or you could say were present 132 seconds ago. And if you look at that, that's kind of crazy. 132 seconds, that's only 2 minutes. So in 2 minutes, we went from 200 grams all the way down to 12.5 grams. All right, that wraps up our notes for today. Tomorrow's assignment, you will be solving problems like this.